So I wanted to write a quick little GORRILAS.BAS style tank game, which should only take about 20 minutes or so and cover a lot of ground. So let's begin by setting up a graphics screen in this QB64 environment, and we'll make it resizable so that it scales to the browser window. I leave a little 20 pixel gap to make a little border that you can right click on just in case. And this should just work, and it does. So let's start with the most important part, that is the tank. Let's put it in a position of XO and YO, and to prototype we'll begin by placing it at the center of the screen, and we will draw it with a simple circle statement, and there you see it. So now we want to draw a cannon on it, and this cannon has to be angle adjustable, and this is where we will have to use some trigonometry. So let's use an angle of pi of 30 degrees, and we simply perform this function. We'll make the cannon about 50 pixels long from the center, about double the tank body, and draw it with a line statement, centering, and we also center the math coordinate system into the basic coordinate system. And this looks correct. So now we want to make this cannon angle adjustable. You could do this with either arrow keys or have a user enter a value, but we're just going to go straight to the mouse. And this is where we introduce the so-called game loop. So every time a game frame is processed and shown to you, we're going to clear the screen, on the top left of the screen we'll print the mouse coordinates. Then we have to redraw the tank every time. And then we have to compute a custom angle every time and draw the cannon. Then we limit our frame rate to about 30 frames per second. And that should just do nothing basically, other than show the mouse coordinates. So this is how we know we're refreshing every time. So what do we do to this angle to make it follow the mouse? For that, since we know the mouse X, which is in some way related to the X component of this angle, and since we know the mouse Y right here, it's going to be somehow related to this Y component. So we have to somehow transform these two numbers into an angle that will follow the mouse. And to do that, we'll use the arctangent function. And this is where it's a little tricky, because really I'm doing something that's like this, but here it's separated by a comma, rather like this, but here it's separated by a comma. So this is the numerator and this is the denominator. And because we have to transform from math coordinates to basic coordinates, you get a expression that looks something like this. Centering it and flipping the y. And this just works. Okay, so now we have a tank and its cannon is fully adjustable. So next we have to shoot projectiles. One thing I'll do is I'll put the tank in the bottom left corner so that we can better see trajectories. And even here you see the consequences of the flipped coordinate system. And I forgot to set these to XO and YO. As well as these. Since I was assuming everything's in the center. But now our tank can freely move anywhere on the screen and the angle structure is preserved. So now we have to catch. Now I'll use the left mouse button to fire a projectile. So now we have to do something like catch that as if it's an event. If I do it just like this, that'd be good enough. Yeah, I see it, but keep in mind that this is going to happen many times a second, which isn't great. I'll keep it like this for now. So every time the mouse is clicked, a small circular projectile will be shot out of the cannon. So let's do it. And this will be the projectile coordinates. And the projectile velocity. Let's say maybe so if the cannon is fired, if shot, we should see a projectile appear as a yellow circle. PX, PY. Let's see. and it does. So now we have to make this projectile move, and we do this by simply adding the velocity to the position every time. And here we're not scaling, but in game dev that's something you'd have to consider, scaling everything. And because we have a flipped coordinate system, we always have to flip the y. So here we see a projectile being shot precisely at the angle. So now we have to introduce gravity. And all you have to do there is subtract from the y component of the velocity every iteration. That was too much, so we scale it down a bit. Make these a little stronger. Make gravity a little stronger. And we have something that fires. And as you can see, I can pretty freely fire this cannon. And every time I fire, it simply resets the projectile back to the origin of the tank. So perhaps the next thing we want to be able to do is adjust power. Maybe based on... Let's try this. Let's see what happens if you do this. Okay. Power. Let's set it to 10. And then this becomes power. Fine. What happens if you do this? Power equals power plus mouse wheel. Oh, so now I can adjust the power by using the mouse wheel. Set it really low, set it really high, and yeah, it's like a laser. Set it really low and we should see nice parabolic trajectories. So now, I'm not gonna bother doing the complete game, but it wouldn't be fun if we can't have these projectiles hit something and explode. So we will try some terrain generation. See if I can just everything looks good here. So we don't need this indicator anymore. This is all the cannon angle stuff. So before we even draw the tank, we're gonna draw the terrain. And let's see if I can just one line this line. Let's pick t equals 0 to screen width. Terrain y. Terrain y is All I'm doing is plotting a sine function that will act as our terrain. And I just want to do this quickly and simply without thinking too much about it. Okay, already that looks pretty good. So let's place the tank just doing this in the B plus style right there. Drop this by 30. Just want the cannon above the terrain. Yeah, that will do. So now I have something of a terrain, and what we want to do is have it not only explode upon contact, but also take a chunk out of it as well. So we'll do this by drawing all of this on a separate page. So this new page, we'll call it terrain equals new image screen terrain and then we go back to now it's destination terrain, then destination 0, that is the viewable screen, and so then we'll have to do the following. Instead of we don't even need CLS, but after CLS, instead of CLS, we're going to put the page containing the terrain. And it works, except that's odd, but whatever. So now the way we determine if a projectile has collided is to see what color is in its coordinates. Okay, so where the fuck was I at? We want to detect collisions of the projectile with the terrain, which we had just drawn, and we will do this by simply looking at its color. So color equals point px py. We begin by just printing it as a sanity check. That's odd, it didn't change at all. But now it changes. So that's for the devs and scholars to figure out. But now you see that as it travels through the cannon, you see all kinds of fancy colors. But once it goes through the green, you see this abrupt change. So all we have to do is catch for this green color and cause an explosion some way. So I'll do this with I'll try with a conditional statement. C equals RGB. Then print collision. And it does not work. So we will try doing more stuff until it works. Okay. Okay, so now it works. So now we know when the projectile is actually hitting the terrain, and we can test it out a little bit, make sure that, check out any edge cases. We should be able to overshoot the mountain, just like that, and no collision. So next, of course, is explosion, and an explosion should take out a part of the terrain and make it open air after the fact. And the way we're going to do this is by simply painting over the terrain. And because we don't have a filled circle in this language, I guess we're gonna have to draw it like this. Let's say 80-ish. And this, of course, will be drawn onto the terrain. see if this works. No, it does work. That's nice. Only thing remaining is the projectile cannot persist after exploding, obviously. So let's just do this. Oh, perfect. And now we can mine across this. The fuck was that? Now we can mine across this mountain. Except let's make the explosion a little smaller by changing the maximum radius. It should be fair enough. Except why doesn't it detect the collision right there? I guess if you use a low power, you don't skip as many pixels at a time, so therefore you're able to get more of this strip mine effect. So with very high power, it will simply shoot right through, like in this case. So you'd have to account for that in a real game. Otherwise, this is pretty much the essence of these kinds of tank games. Yeah. So I guess just for fun, we must draw some kind of a pretty explosion. And I guess let's do that. First do black. Well, it doesn't matter what happens first, but let's draw a little explosion. Equals 0 to 50. Okay. Not bad. Yeah. Maybe more of a orange color. Not very explosive in its velocity. Yeah, good enough, I suppose.